Today we have two learning goals we want to look at. Those two learning goals are you will determine the intervals in which a function is increasing, decreasing, or constant. The second one is you will find and identify extrema of a function. Those are the two things we're looking at today. All of this will come from looking at a graph. We will determine everything from a graph. So let's get started on page 40. We're going to be looking at number 1 to begin with. So, we're determining if a function is increasing, decreasing, or constant. What is the function doing if it's increasing? Going up, be more specific. I need to say something else besides going up. There has to be something else.
One x value doesn't equal 2 y values.
1 x value. Alright, that's a function. But I want to know, like this, the first part of this graph on the left side, what's it doing? It's increasing. You have to do, it's going up as you move from left to right. Okay, a lot of you were saying going up, but I could say this piece right here, wherever it's at, I could say that piece right there is going up if I said I was going from right to left, correct? Okay, so you have to do more than just say going up. Okay? So a function is increasing if it's going up as you move from left to right. Alright, now the trickiest part of doing the intervals of increasing, decreasing, or constant is the fact that you have to use domain values. So what does that mean? I have to use x values. A lot of people get this screwed up because they use y values. You have to use x values when you're describing intervals of increasing, decreasing, or constant. Okay? So it's very similar to when you were finding the domain. When we were finding domain, what did we do to get started? We found the leftmost value. That's the same thing we want to do on this. So what is my leftmost value on this problem? Negative infinity. So I write that down. So I find my leftmost value. The next thing I want to do is determine, is this thing starting out increasing, decreasing, or constant? It is increasing, so I want to write down increasing. And the next thing I ask myself is, when does it stop increasing? Negative 1's close enough. Okay, I just don't want to hear 4. Did anybody want to say 4? Why did you want to say 4? What type of value is 4? It's a y value. Remember what we just say that the biggest issue with this is? You have to use x values. Get away from the y value when you're doing this. So, my x value we're going to call negative 1 there. Okay, so then we started over at negative 1. What's my graph doing as I get past negative 1? It is decreasing. Okay, where does it stop decreasing at? Yeah, we can go positive 1 there. Make sure you're using the x value and not the y value again. Okay, and we start over at 1. What's it doing at 1? It is increasing, so we write down increasing. And where does it stop increasing? It goes to infinity. So there are the increasing and decreasing intervals of this function. Again, how do we get started, Blake? Christian, how do we get started? Leftmost value, and then Rachel, we decide.
Where it stops.
Before that?
Whether
or not it's increasing or decreasing, and then we decide where it stops. And we continue to do that until we have all the graphs. Okay, let's try another one. Alright, so I have this function. So Reagan, get me started on this one.
So, we have to find out if it's where the xmost value is.
The leftmost value, so what is my leftmost value?
30.
Negative infinity is my leftmost value. You're not helping anybody when you do that. Okay, breathe in. What do we decide next after we have our leftmost value?
Is it increasing or decreasing?
All right, what's it doing? Decreasing. Very good, Lindsay. What do we do next?
Find out where it quits decreasing.
Okay, where does it quit decreasing? -1. So where are you seeing -1 at?
Well, it can't cross over the line, right?
Oh, so it can cross over the line. All we care about is where does it stop decreasing. At 2? All right, I'll go with that. Very good. So it stops decreasing right here, and we're going to call that 2. I'm happy with that. Okay. Bobby, what's next? All right, so you're saying it increases, so we start at 2. It's increasing, and Bobby, where does it stop increasing? At infinity. So we're going to say it goes to infinity. So this one is decreasing from -infinity to 2, and then increases from 2 to infinity. Yes?
Do you always use parentheses?
Good question. Whenever you're dealing with increasing, decreasing, or constant intervals, you always use parentheses. Excellent question. All right, next one. All right, Gage, get me started on this one.
That one, I would say -infinity to 0, it increases.
Very good. So -infinity is my leftmost value. It is increasing, and it stops at 0. What's going on with this graph at 0? Anybody? What do you got?
It gets pretty stinking close to 0, but never quite 0.
So what's at 0?
Nothing.
No, there's something there, mathematical, that's there.
Whispers failed.
Starts with an A.
It was a bad word, so like not a bad word at the same time.
Asymptote is what is there. That is correct. And there's an asymptote at 0. Anytime you have an asymptote, that has to be part of an interval. So since I see an asymptote at 0, I know my interval has to stop at 0. Okay? Very good. Kathleen, what's another interval?
From it's not quite 0, so we'll go. Well, can we say 0?
We can still say 0.
Okay, 0. Then 2.
Infinity, and what's it doing? Say it again.
Increasing.
Increasing, very good. So this one is always increasing, but I cannot say from -infinity to infinity because what? Because there's an asymptote there. You always have to identify the asymptote. Very good. Hey, Bailey, get me going on this one.
Negative infinity to
-infinity to -2, what's it doing?
-2. It's increasing.
It is increasing. Kendrick? Next one?
0 to 4 is decreasing.
0 to 4, it is decreasing. Kurt?
4 to infinity, it's increasing.
4 to infinity is increasing. Very good. Any questions on that? You guys alright? You're concerning me. Alright, Cam, get me going on this one.
Negative infinity to
-5, what's it doing?
What if this is not
So what is our other option?
constant?
Constant. Okay, AJ, give me the next one. Alright, we'll go with -3. What's it doing there? Increasing. Alright, Nick, what's the last one? Very good. -3 to infinity decreasing. Alright, any questions with those intervals? Yes.
Why is it constant instead of increasing and decreasing?
Here?
Yeah.
Because it's
Just
flat.
'cause it's flat.
Anything that's flat is constant. Good question. Alright, so that is our learning goal of determining intervals of where a function is increasing, decreasing, or constant. You call in when we're doing these, how do we get started on those? Leftmost value, determine if it's increasing, decreasing, or constant, and then figure out where it stops. Okay? And Christian, we've got to make sure we use what values when we're doing the intervals. Got to make sure we're using x values. Good. All right, so now we want to look at finding and identifying extrema of a function. Anybody know what the word extrema is talking about? Do I have any prior experience with the word extrema? What do you got, Kristen?
I don't necessarily remember. I think it has something to do with the X value.
Okay, what is the word extrema very close to? What other word is extrema very close to? Extreme. So extreme, we're talking about a maximum or a minimum is what we're talking about here. Identifying maximums and minimums. There are two different types of maximums and minimums. Okay, these two words go together and those two words go together. They are synonymous with each other. Okay, the first type of extrema is called relative or local. Those two are the same type. Okay, the other type of extrema is called global or absolute. So we have relative and local extrema. We have global and absolute extrema. On the relative extrema, those happen where my function changes from increasing to decreasing or decreasing to increasing. That is where relative extrema occur. My function must change from increasing to decreasing or decreasing to increasing. So in this particular problem, we first want to identify our relative extrema. Okay, so I'm going to go ahead and identify them, and then I'll come back and talk about what's going on. And here's how I want them written. And let's call that, we'll just call it -1.5. Okay, notice I did two things on each of my relative extrema. I first identified the x value where the extrema is at, and then I identified the y value of the maximum or the minimum. Okay, so we've got maximums here and there. Why do I have maximums there? What is my function doing at those two spots? Changing from increasing to decreasing. When we justify a relative maximum or a relative minimum, that's how we want to justify it. It has to change from increasing to decreasing or decreasing to increasing. So on maximums, my function must change from increasing to decreasing. So that's what's going on there. So I identify the location where it occurs, identify the x value, and then I identify the y value of the maximum. That's how I want it done. Then we have a relative minimum at 0, and my relative minimum is -1. So it occurs at 0, and the y value of it is -1. So what's my justification on why that's a minimum? My function is changing from decreasing to increasing. Now, when you justify these to get you ready for calculus, we have to be very specific on how we speak and what we use. The word it should never be used. Okay? We never want to use the word it whenever we're describing something, because it could be anything. We want to be as specific as possible. And in this case, what's the name of my function? F of x is my function. So when we talk about it, we want to talk about f of x. So if I'm going to justify a minimum, I want to say f of x changes from decreasing to increasing. If I want to justify a maximum, I want to say f of x changes from increasing to decreasing. Okay? So identify the x value where it occurs, and then identify what the y value is. Okay? Now, let's talk about global and absolute. When we're talking about global and absolute, we're talking about what is the highest high value or what is the lowest low value. Okay? In this particular problem, do I have the highest high value?
Yes.
Yes. Where is it at?
3.
Relative max.
It's the same place as that relative max. So I can go back in here and say this is also an absolute max. Okay? What about an absolute minimum?
Gonna be negative.
Right. We can't use infinity though. So if it goes to one of the infinities, that means an absolute minimum does not exist. So in this case, there is no bottom to this graph. If there's no bottom to the graph, I cannot have an absolute minimum. There has to be a bottom or there has to be a top to have an absolute. If I don't have a top or a bottom, no absolute. So in this case, I have absolute maximums at the same place I have relative maximums. Okay? Questions on that? All right, let's look at the next one. All right, so here's my next one. So, Kurt, get me started on this one. Give me a relative extrema that you see.
0.
Okay, now I want you to word it like we had it worded. So, relative what?
X
Relative what?
Maximum.
maximum.
Relative max
At x equals
at x equals
0.
0 is
0.
0. Very good, there's one of them. Okay, Matt, give me another one.
Relative minimum. See if I understand this correctly. Negative 3.5, 3-ish. Is negative, like 1,000.
Oh yeah, I didn't see
Or
800 there. But yeah, so that would mean each of them is worth 400. So it's got to be at least 1,200.
Yeah,
So let's call it 1,300.
Okay.
Yeah, I hate when they do stupid stuff like that on the graph. Yeah, I'm glad you caught that. I didn't catch that first time. Negative, yes, thank you. Okay, Gage, give me the other one. There's one more. We've got this one. We've got that one. There's one more.
One over there.
Okay, so what is it? A maximum or a minimum?
Minimum.
Minimum. And what x value is it located at?
3-ish. 3.5.
3.5. Okay, and what y value goes with it?
Negative 900.
All right, negative 900. Let's call it negative 1,000 since it's pretty close to the middle. Okay. So, Bobby, what is my justification on why there is a maximum at x equals 0? Why is there a relative maximum at x equals 0? What's my justification? You said bad word.
Say
My function is called f of x. So whenever you're talking about f of x, say f of x. So because f of x changes from increasing to decreasing, that's what I'm looking for here. Okay? And AJ, what are my justifications on the minimums? Okay, AJ, what are my justifications on the minimums? Cam, what's my justifications on the minimums? Lauren, justification on minimums.
Because f of x is decreasing.
Changes from decreasing to increasing. There's two words I want. I want the function name and I want to hear changes. Okay? Function name changes and it's got to be increasing to decreasing or decreasing to increasing. Okay, Kendrick, what about absolute max or min? Is there an absolute max or min in this case? Bailey? Absolute max or min?
There's absolute minimum.
Where?
-13.
Okay, so this one right here is also an absolute. Kurt, why is that an absolute? Because it is the lowest point of my graph. So the very lowest point of my graph is going to be an absolute minimum. Kaya, is there an absolute maximum? Why not? Because my graph keeps going. Okay, my graph has to stop in order to have an absolute max or minimum. It does not stop going up, so that means there is no absolute max. It does stop going down, so that's why there's an absolute minimum. Excellent. All right, Nick, give me a relative extrema on this one. Where?
X equals -1.
And it is what? -4. What's your justification on why that's a minimum?
What?
There's two words I want to hear. F of x is the first one. What's the second word I want to hear? No. Changes.
Changes.
So how does it change at that spot? From what to what?
From decreasing to increasing.
There you go. That's why it's a minimum. F of x changes from decreasing to increasing. Very good. Natasha, what's my other relative extrema? Okay, why is it a relative max? Excellent, because f of x changes from increasing to decreasing. Very good. Rachel, do I have any absolute extrema? Why not? Okay, because I have no bottom to this graph and there is no top. If there's no top or bottom, there can be no absolute extrema. Very good. All right, Bree, give me a relative extrema on this one.
Relative max at x equals 2 is 0.
Okay, why is it a relative max?
X changes from increasing
You're close. What's the name of the function?
to f of x.
F of x changes. I thought you just said x. Did you just say x? Is that what I heard? Good. Very close. So, maximum there because f of x changes from increasing to decreasing. Very good. Reagan, what's my other relative extrema?
Relative minimum at
At 1.25, and what is it?
-1.25
Okay, why is that a relative minimum?
because f of x changes from decreasing to increasing.
Very good. It's because f of x changes from decreasing to increasing. Okay, Lindsay, do I have any absolute extrema? Why not?
Because there would be a negative.
Because there is no bottom and there is no top, so that tells me no absolute extreme. Good. All right, AJ, give me a relative extrema.
Relative max
what is it?
-1.
Alright, -1's close enough. Why is that a relative maximum? Oh boy.
That's where f of x changes.
From?
Decreasing, not from increasing.
Alright, thank you. Alright, Cam, give me another one.
Negative approximately 1. And it is -8.
Okay, why is that a relative minimum?
Because f of x changes from decreasing to increasing.
Because f of x changes from decreasing to increasing. Very good. Blake, do I have any absolute extrema?
You do not,
Why not?
because they go to infinity. There's no bottom or top.
There's no bottom and there's no top. Very good. So that is finding relative extrema, or that is finding extrema. We have two types, relative, local, and we have absolute and global. Bobby, where do relative extrema occur? What's the graph doing? At relative extrema. It's doing one of two things to have relative extrema. Where it's changing from increasing to decreasing or decreasing to increasing. That's where relative extrema occur. Colleen, how do I find absolute extrema? Absolute or global? The highest high or the lowest low is absolute. Very good. So that's finding and identifying extrema of a function. We also determine intervals on which the function is increasing, decreasing, or constant. Lauren, when I'm doing intervals of increasing, decreasing, or constant, what should I start with?
The farthest to the left.
The leftmost value, and then Kendrick, I determine if my function's doing what?
Changing.
Not changing, if it is increasing, decreasing, or constant. So I determine my leftmost value, determine whether or not it's increasing, decreasing, or constant. Then I decide what the right is, and then I continue to do that until I'm all the way to the right. Okay? So those are your two learning goals right there. Here's your assignment.